Throughout Chapter 6, we learned about properties of trigonometric functions, the unit circle, and how to solve for angles and measurements.
These concepts are important because they are the basis for the concepts that we've used to advance throughout the first semester.
This chapter is also important because it can be used to find the distances, heights, and angle of elevation.
Something we learned to use to find that angles and side measurements of triangles are SOHCAHTOA, sine of theta equals opposite over hypotenuse, cosine of theta equals adjacent over hypotenuse, and tangent of theta equals opposite over adjacent. And it's the reciprocal for the opposites of each of these. So cosecant equals hypotenuse over opposite, secant equals hypotenuse over adjacent, and cotangent equals adjacent over opposite.
The unit circle is a circle with a radius of 1 whose center is the origin of the basic rectangular coordinate system. The unit circle is typically used to find basic trigonometric identities by using the angle measurements in degrees or radians. Conversion chart is right here. We can typically create a right triangle and infer the x and y values of said triangle in order to calculate the sine, cosine, and tangent of it. When solving for these trigonometric functions, be aware of the quadrant to ensure that you have the correct negative and positive answers. The unit circle is represented right here. So when we said that they have a radius of 1, the 360 or 0 degree would have 1/0, and then the rest is 0, 1, -1, 0 for the negative quadrants, and then 0, -1.
Alright, so another thing that we learned were the reciprocal identities. Cosecant is 1 over sine, secant is 1 over cosine, and cotangent is 1 over tangent.
Another thing we learned in Chapter 6 were the important identities that can be used to solve problems. For example, tan of theta equals sine theta over cosine theta. Cotangent theta equals cosine over sine theta, which makes sense because cotangent is reciprocal of tangent, so they switch. Sine squared theta plus cosine squared theta equals 1. Tangent squared theta plus 1 equals secant squared theta. And 1 plus cotangent squared theta equals cosecant squared theta.
Lastly, when you convert from radians to degrees and degrees to radians, you have to multiply the numerator by 180, and then you multiply the denominator by pi. So that way the two pi's can cancel out and you get a degree in like a regular number. And then when you convert from degrees to radians, you have to multiply the numerator by pi and then the denominator by 180, so that way you get a fraction. So an example problem for converting it from radians to degrees could be used by converting 3 pi over 2. So you have to write out 3 pi over 2, and because you want it to be degrees, you have to multiply it by 180 over pi. That way your 2 pi's can cancel out. But then we can simplify it even more, and we can take out the 2 in the denominator, so that will be 1, and then we can take out a 2 here, which leaves us with 90. So then we have to multiply 3 by 90 degrees, which leaves us with 270, and that's our answer.
So to convert 135 degrees to radians, we know that the formula for that is to take the number or the degree that you have, which is 135 degrees, and multiply it by pi over 180 to get radians. And that comes up to be 135 pi over 180. And you can simplify by dividing each of these numbers by 45, and you get 3 pi over 4.
Alright, so we need to find the exact value of tan pi over 4 minus sine 3 pi over 2. So first we're going to refer to our unit circle, find pi over 4, which is 45 degrees, and find our x-coordinate and our y-coordinate. So our x-coordinate and y-coordinate are actually the same for pi over 4, and that's going to be radical 2 over 2. And then we're going to find tangent of pi over 4, and tangent is sine over cosine, or y over x. So we're going to rewrite the problem as radical 2 over 2 divided by radical 2 over 2. And when dividing fractions, you copy, switch, flip. So I'm going to rewrite it as radical 2 over 2 times 2 over radical 2. And all these values cancel each other out, so we end up with positive 1. And then we're going to refer back to our unit circle to find 3 pi over 2, which is down here, and that the x-coordinate and y-coordinate are going to be 0 and negative 1. And once we write those down, we're going to find sine of 3 pi over 2, and sine of 3 pi over 2 is the y value, is the y-coordinate, so it's going to be negative 1. And then we're going to rewrite our entire problem, but with the values that we found out, so it's going to be 1 minus negative 1, and the two negatives equal to a positive, so it's going to be 1 plus 1 equals 2.
So to find the exact value of using tangent or any other function and a degree, you have to use the unit circle. So you would, to find the exact value of tangent of 60 degrees, you would have to draw the unit circle and draw your 60-degree triangle. So that's a 60-degree triangle, and the coordinates for that are 1/2, comma, radical 3 over 2. So when you find tangent, you want to use one of our special identities, which is tangent of theta equals sine of theta over cosine of theta. And the x value is always sine, the y value is always cosine. So you want to do tangent of theta equals 1/2 over radical 3 over 2. So then you have to multiply by the opposite reciprocal because you can't divide by a fraction. So you multiply tangent of theta equals 1/2 times 2 over radical 3. But the 2's cancel out, and then you're left with 1 over radical 3. But you can't have a radical in the denominator, so you have to multiply by radical 3 over radical 3. And then these two, the two radicals, when you multiply two radicals, they cancel out, and they leave you with just the number underneath. So it's radical 3 over 3 is the tangent of 60.
Okay, so this problem asks if sine is less than 0 and cosine is less than 0, to name the quadrant in which the angle theta lies. So in order to figure this out, you want to draw your unit circle with all students take calculus to figure out positives and negatives in which quadrant the angle theta would lie in. So if sine theta is less than 0, that means that sine can be positive and all of the identities can be positive. And if cosine theta is less than 0, that means that cosine can be positive, which means angle theta lies in the third quadrant. And just for reference, sine of theta equals y, cosine of theta equals x, tangent of theta equals y over x, cosecant of theta equals 1 over y, secant of theta equals 1 over x, and cotangent of theta equals x over y.
Alright, so with this problem, we need to find the exact value of secant 25 pi over 6. It's hard to find 25 pi over 6 on unit circle, so we know that 6 goes into 24, so I'm going to subtract 24 from 25, which gives us 1. So now we can rewrite 25 pi over 6 as pi over 6. And then we're going to refer back to our unit circle. Pi over 6 is also at 30 degrees. And we know that our x-coordinate for pi over 6 is radical 3 over 2. And our y-coordinate is 1/2. And we're looking for the secant of pi over 6. So secant is 1 over x. So I'm going to write 1 over, and then our x value, which is radical 3 over 2. And then usually when you're dividing fraction or fractions, you have to copy, switch, flip. So I'm going to rewrite this as 1 times 2 over radical 3, which gives us 2 over radical 3. But we can't have a radical in the denominator, so we're going to multiply radical 3 by itself, which will give us 3. And you also have to multiply the same to the top, so 2 times radical 3, which gives us 2 radical 3. And our final answer is 2 radical 3 over 3.